Good afternoon, everybody. Chris Heacock's here, live in the Woltosz Theatre at the Jay and Susie Gogue Performing Arts Center. I'm glad to have everyone, welcoming everyone here today for our Talkback Thursday with Russ Todd. Russ, good to see you.
Good to see everybody. Hope everybody's doing well, and it's great to see Chris here in the hall in Auburn. I can't wait to see him again live there.
Ditto. So, for those that don't know, Russ Todd is an acoustician, one of the managing partners of the company Akustiks, which was one of our consultants on the Gogue Performing Arts Center project here at Auburn. Russ, why don't you tell us a little bit about how you guys came about in this project and what it is that you guys do at Akustiks?
Well, sure, Chris. Our firm, Akustiks, is a specialty firm focused in the acoustical design of performing art spaces. We also design museum acoustics as well, but our real focus is developing spaces where sound is a critical part of the program and activity. I have three partners, and we all have some sort of music background combined with both architectural engineering and then just real world live experience. And we bring all of that to bear on the design of projects. Let me start by saying the opportunity to be a part of such a wonderful project here at Auburn was truly an honor for me personally. Auburn is my hometown, and the wonderful leadership that had a vision for this project to create a space with world-class acoustics, through to the team at Auburn, the design team. It really does take a village to create a space like this.
Yeah, and we were very fortunate. Our friends at Wilson Butler Architects brought you all on board for the project, along with a lot of other different companies to be able to put this together. And then it was up to Rayburn General Contractors here locally to get those plans and put it into place. So yes, we're very happy about that. So wanted to kind of start with, those that have been in the theater and those that have not. What was the goal for Akustiks in the Woltosz Theatre from the get-go?
Well, I think it really starts with the envisioned programming of the theater. And the Woltosz Theatre is what we call a multi-purpose or multi-use theater, in that it can host a wide range of program types, ranging from a orchestral classical music performance to there we go, we've got some great images here, to a Broadway style performance, opera, in the case here of Renee Fleming, to fully amplified type performances. I think this is Bela Fleck and the Flecktones. By the way, Chris, the first year programming was spectacular, and there we go. Here's a Broadway presentation in the hall. I believe this was The Rent, or Rent, and why I say it's spectacular from my standpoint as an acoustician is that it really highlighted the range of acoustic requirements that the hall is able to meet, and that is that range from an orchestral, amplified, to spoken word type performance.
Yeah, so the goal was really to have as flexible a space as we possibly could for the multitude of programming that we would have here, but with an attention to detail on acoustics, either classical, non-amplified, but also amplified. So when you guys go into a a project like that, what are some of the things that you're really thinking about to make sure that, on one day you have a, wonderfully tuned concert hall, and then the next day the hall is dead as possible so that you can amplify it?
Well, one of the things that we don't do is we don't design a compromise situation. The design goal and the direction we take is really to optimize the acoustics for the different program types. So for example, and really we start with the orchestral format, in that we have to create an acoustic that fully creates the room reverberation and resonance that is required to support the sound from the orchestra, to blend the sound of the music. So in order to do that, we really start out with a fundamental equation, which is the room reverberation or Sabine equation by the Wallace Clement Sabine, who developed this in Boston, that led to the design of Boston Symphony Hall. And that equation basically determines the reverb time based on the acoustic volume of the space. And we also know that as we increase the reverb in a space, we create this blending, and we kind of know from experience and the great concert halls around the world what the ideal reverb time is for orchestral performance. And that's around 1.8 to 2.0 seconds. And that's how long sound sustains in the room. So at the very beginning of the project, and meeting with the architects, we established the acoustic volume of the room per seat count. And that number was around 350 to 400 cubic feet of volume per seat. So as the acoustic volume goes up, the reverb goes up. We use the seat count as an important part of that equation, because in a concert hall, the primary absorption in the space is the audience, or
Right.
the seated people. So as we add more people to a space, the reverb actually goes down. So we developed this ratio, this volume to seat count ratio, that we used to calculate that. That was established, which basically gave us the overall dimensional aspect of the hall. And then we have the ability to adjust the acoustics from that long reverb time for orchestral to a lower reverb time for amplified performance, because when we are mixing at a soundboard for an amplified group or spoken word, the reverberation can actually blend and mask the sound. So we use what we call adjustable acoustics, which are basically soft goods that we bring into the room to dampen that reverberation. So that's the very beginning or essence of the design.
So one of the questions that we get a lot when people come into the space is about the grills that surround the theater, and I think we have a photo up about that. And talk about pulling in drapery or material to deaden the sound. Will you talk a little bit about
Sure.
those wooden grills, and then what is behind them?
Right. Well, actually, what you're seeing with the wooden grills is the architectural definition of the room. In other words, it's the visual room, and it's important in a theater space that a room feel intimate. And by bringing the walls in visually, it creates a greater sense of intimacy. However, at the same time, as I was just describing, if you go back to the image prior, which shows the entire room, you can see the wood grills with this blue color behind. Well, there's about a 10-foot space behind those wood grills, if you go back in depth, that is this acoustic volume that I'm talking about. And that, there you go, there's the space. By adding this acoustic volume to the room, we're now introducing this necessary room reverberation. When we go to the amplified mode, we then bring acoustical absorption. If you go to the photo that we were just looking at, the prior photo, The blue material that you see on the right is this acoustical absorption that we can bring into that chamber, if you will, to dampen the acoustics for the amplified use. That material is actually a wool material. It's very, very soft, and it absorbs sound. So we can then adjust the acoustics, the room reverberation of the space, depending on the program, and without changing the visual appearance of the room. As a matter of fact, I think the opening weekend, we changed the acoustics from, we started out, I believe, with an opera presentation. We had a very reverberant space, and then during that program, we brought in the adjustable acoustics for the jazz portion of the program.
Yeah, that's correct. It was a good test for the first performance in the theater, and I think it worked out very, very well. But you know, it's really interesting. You know, we have the walls and the grills, but you know, I'm sitting in the theater, and it's all the material also, which I think is one of the things that not everybody understands. It's, you know, all of the seats that are in here are all wood. There's no plastic. So it's wood reverberates very differently than a plastic or a metal shelled seat. You know, the fabric that's on all the seats, all the wood that's in the room. And the other thing that I always find very interesting is the plaster. I mean, we don't have drywall in the theater either. It's all hand plaster. Will you talk a little bit about that as well?
Well, if we go back to that reverb equation we just were describing, where we have absorption lowering reverberation, if we were to add a whole bunch of soft material to the room beyond the people, we're now lowering the reverb. So when we think about the surfaces and the materials of the hall, we want all the surfaces except for where we're actually seated, which is the padded seat, the seat back, to be acoustically reflective. And thus, if you look at your beautiful wood seats, which are spectacular, by the way, the wood is absolutely gorgeous. It's a reflective material. The balcony fronts are reflective, and then to your point, the wall surfaces are plaster on masonry, and we really have learned this from the great concert halls of the world, the Musikverein in Vienna, or the Concertgebouw in Amsterdam, or even Symphony Hall in Boston, where the wall surfaces are plaster, which are very massive and heavy. So what does that do? When the sound that propagates out into the room impacts that wall, it reflects back into the room so that we can hear it. If it were a lightweight material like drywall, or if it were a absorptive material, that reflection wouldn't occur, and we wouldn't hear this room reverberation and resonance. Yeah.
Yeah, and you know, we really don't know what our patrons' reactions are going to be, or even our artists, until we get them in the hall. I think one of the really great things in the opening season that we've learned is that the space has been not only great acoustically and visually for our patrons, but also our artists. You know, from the first artist we had in here to the last one we had in here, it's been really, really amazing. I know I've shared some of that feedback with you. Everyone from Renee Fleming to you know, Simona Dinnerstein, pianist who was recently here. You want to talk a little bit about that as well? Maybe some of the feedback that you've received.
Well, I think the slam dunk comment was as good as it gets, but really, I think what's important is that artists feel comfortable in the room, and it actually starts both with what we were just talking about, the materiality, the characteristics of the room, but also the stage.
Right.
And we've designed an orchestra shell on stage with orchestra towers that diffuse and blend the sound across the orchestra. And for singers, for example, the room has a 4-stage reflector, a reflecting element that is just downstage at the proscenium that provides lift and support for singers. So when an artist is in the room, they're receiving these supporting reflections from the stage, but they're also receiving acoustical reflections from the room back to them that then actually helps to connect the artist to the performers. And it really is the job of the design team as a whole to make that connection. I think that's the ultimate goal, is to connect the audience and performers. Once that happens, it's really musicians experiencing, enjoying the space, and then if they really have a good experience, they'll spread the word about that, and hopefully they'll come back. That's the goal.
That's what we've heard too. I mean, we have a number of artists that want to come back, and artists that have, classical artists that we've had on the season want to come back and record on the stage, and that's a wonderful wonderful feedback to get from those artists, that they feel strongly enough about the acoustics in the space that they would want to record in the
That's
hall.
great to hear. Yeah.
So again, we're Chris Hecox here, Executive Director of the Gogue Performing Arts Center at Auburn University, with our special guest Russ Todd from Akustiks. And Russ, you kind of hinted on our Talkback Thursday next week. Next week, we're going to have our production team here at GPAC showing how the acoustical shell goes up and what it looks like, all of that. So tune in next week. A little bit of a commercial for next week, Thursday, 1 p.m. Central, 2 o'clock Eastern, and Taylor Dulesky, our Director of Production, and his team will be demonstrating the acoustical shell. We had a couple of questions that I wanted to address now. We have one from Nora Patterson. Nora asks, how has acoustic design changed since you started doing this?
Well, I think that as a industry, we've really gotten a good handle on the technical aspects that make a room really great. And a big part of this has been, some of the great halls that I just mentioned, the Music Verein, the Concertgebouw, these were designed and built in the 19th century. They're still considered the world's greatest concert hall. So, before I get too happy here, we still have a lot to learn probably. But I think the ability to understand, to using instrumentation and testing, we've had as an industry the ability to really quantify what makes a great sounding space. We also use technology to model the acoustics in a space. We do that both electronically. We can actually also build scale models. And actually at Akustiks, we believe that spending a lot of time in full scale models, which are the great halls, listening, observing, and really trying to identify what are the key attributes that makes a great room. For example, the Woltosz Theatre is a shoebox hall in form with respect to the sidewalls. Mm-hmm. And then the rear of the room is the traditional horseshoe opera house form. Well, if you were to look at the dimensional aspects of the sidewalls in the Woltosz Theatre and then travel to Vienna and look at the Music Verein, you'll find some similarities to that. The width of the room, the arrival of what we call lateral acoustical reflections to the audience from these sidewalls is what gives us the spatial impression of sound. And we now have the ability as an industry to model that, understand that, and incorporate that into the design.
Well, I will have to say that I've continued to and have learned a lot from you, Russ, throughout this process. But I wanted to tell one of the great stories in the construction because I think it tells a lot about this space. Russ, on numerous occasions, had to come down and test the noise in the space because, again, noise is not our friend. We want it to be as quiet as possible. And so our first run at it, we found a noise, and you want to tell the story, Russ?
I'm trying to remember which noise this was that we found.
I'll go ahead with it.
Yeah, go ahead, and I'll jump in. Yeah,
we were standing on the stage, and there was and for our musician and acoustical friends out there, it was an octave hum that was happening. So Russ, from doing this for a long time, knew that it was more than likely a fan. So, the first thing you think of is an HVAC system. Shut
Right.
the HVAC system down, and it was not that. Went up in the grid, which was what, about close to 80 feet, 70 feet up,
80 feet up in the air. Yeah. Yeah.
found a electrical router for lighting
Right.
system that had a small fan turning, and we could hear that noise. That's how quiet the space was, and we're able to, find a solution for that fairly easily to get rid of that sound in the space, which I think really tells the great story of all the work that everybody put into making sure that, number one, the space was as quiet as possible from an acoustical standpoint.
Absolutely, Chris. I think that story raises a great point in that in order for performers to have a full dynamic range of sound, and often in our office, we'll say that often the magical moments in music happen on that edge of silence.
Mm-hmm.
So you have to create the silence. You have to create if you were a painter, it would be the white canvas so that the artist can then paint on that white canvas. Mm-hmm. And in order to create that complete silence takes an enormous effort from so many people. It's making sure, for example, that the mechanical equipment and the building that houses that is completely separate from the hall, and we do that with what we call an acoustic isolation joint. Well, the Rayburn team went to great effort to make sure that isolation occurred. And once you achieve that, to experience that silence or that quiet, and if you think about it, if you were to just play the softest note on a violin, let's say, that's not much louder than that little fan that you just described. And you want to hear that softest note at throughout the hall. So in order to hear that, if we have noise that's in the space, mechanical noise or something else, you don't hear that softest note. So I think that's a very important part of the design, and something that really does take or took the entire design and construction team to create.
Yeah, and I think one of the things that we realized when we first started getting into the space too is how deafening that silence is, which is great. But it really
Right.
is, until you've been in the space when no one's in here and you really experience it, it's quite deafening, which is a wonderful.
It's a tribute to the team. Yeah.
Absolutely, to everybody on the team. I wanted to, before we run out of time too, I wanted to talk a little bit about our outdoor space, our amphitheater at the City of Auburn Lawn and Porch. And you were talking a little bit about the modeling and how you model, but we actually did some computer modeling for this as well. You want to talk about how we designed that space too?
Well, I think part of that design was looking at the orientation of the theater, the outdoor venue, to try to orient the propagation, away from the neighborhood, and that was done with computer modeling. Also, computer modeling was used to optimize the sound system design that's out there. Now, I will say that's not my specialty. It's I've got a team of guys. I'll give a shout out to Jordan Lytle in our office, who led the audio design for the project. But we use that computer modeling really to optimize the design of the audio systems, both in the Woltosz Theatre and in the Auburn Lawn and Porch. I would also note that one of the design aspects of the outdoor venue is the stage area with articulated and absorptive treatments, so that folks that are on stage feel comfortable there as well. Just like we have an orchestra shell that we use on the main stage, the sidewalls and the ceiling of the second venue. If anybody has an opportunity just to walk up there on stage, you'll see that acoustic treatment there.
Yeah, it's not just, cinder block up there. I mean, they're articulated. They come to a point. There are slats where there's acoustical material behind them, and then in the ceiling as well, we have the acoustic battens up there for absorption, which is something that we added late in the process also to make sure that it just doesn't reverberate all over the place.
And for the physics guys there at the university, those are Helmholtz resonators. So folks can look that up. The slots that you see in the block are what we call a Helmholtz resonator.
Gotcha. Well, we're just in a little intermission right now, Russ, and we're looking forward to getting people back into the theater and back to the Gogue Center. Why don't you tell everybody a little bit about what you guys at Akustiks are working on right now? I know you're still staying busy, so why don't you kind of talk a little bit about that for us?
Sure. Well, it's interesting because we all are working in a challenging time right now, and we've really learned how to do this kind of design process. But one of the primary projects that's ongoing and actually accelerating a bit is the renovation of David Geffen Hall at Lincoln Center for the New York Philharmonic Orchestra. We're also in construction as we speak on a new 1,800-seat hall in Nashville for Belmont University, and the University of Miami. We're working on a recital hall right there down in Miami. So
in Coral Gables, yeah, that's great.
Coral Gables, yeah,
absolutely. Well, we're thrilled to have you here, at least virtually, and looking forward to getting you back. For those that missed the very beginning, Russ is from Auburn, grew up here in Auburn, went to Auburn High School, was in the jazz band and on the football team. So very glad to have Russ as a part of our Talkback Thursday today to talk about the acoustics in the Woltosz Theatre and also our amphitheater at the City of Auburn Lawn and Porch. Russ, great to see you virtually and looking forward to seeing you again very soon here in Auburn.
Well, it's great to see everybody, and thank you for having me today, Chris. And I so look forward to being back in the hall and seeing everybody enjoying the Gogue Center. Yes.
Great. And just a reminder to everybody, we'll have another Talkback Thursday next week with our production team, led by Director of Production Taylor Dulesky. They will be showing how the acoustical shell works, which we talked a little bit about here with Russ. We also, season tickets, our Create Your Own series is on sale right now for the 2021 season. You can go online to gougecenter.auburn.edu. You can always call our box office at 344-844-TIXS, which is 8497. Russ, great to see you again. Look forward to catching up with you soon.
Bye, everybody, and War Eagle.
War Eagle, everybody. Have a great day.